Okay, so let us start with today's class. Yesterday, have you worked out with that problem? How to convert NFA without epsilon to NFA, sorry, NFA with epsilon to NFA without epsilon. I gave you one practice problem, right? Have you done that?
Yes, ma'am.
Yes, ma'am.
Okay. So no doubts regarding that, right? Shall I proceed to the next topic?
Yes, ma'am.
Okay. So in this class, we will see how to convert NFA to DFA. So as we have already seen, when the requirements are not clear or when we are not very sure, so first we proceeded with NFA with epsilon. Later on, when we know few requirements, we have changed it from NFA with epsilon to NFA without epsilon. Again, we will be converting that to DFA for further perfection. So now in this class, let us see how to convert NFA to DFA. So the problem is we are taking a phi tuple. So this is the definition of NFA. So Q, sigma, dou, Q naught and F. So this is taken as a NFA which is accepting a language. So L of M it is accepting. So M is the phi tuple. So it is accepted by a language L. Then our aim is to find an equivalent DFA. It is denoted by M dash. So here all the phi tuple we will be indicating it with a hyphen. So just to show that, so this is a changed one. Okay. So Q dash, sigma dash, dou dash, Q naught dash, F dash, such that L of M is equals to L of M dash. In simple terms, to say we have to find an equivalent language to L of M, that is L of M dash. L of M is the language that is denoted by NFA. L of M dash is the language accepted by DFA. So now we are trying to design an equivalent language accepted by a DFA to the language that is accepted by NFA. Given a language L of M which is accepted by NFA, our aim is to find out a language L of M dash which will be accepted by DFA. So okay, let us see how to convert NFA to a DFA. So here we have the procedure. So initially we will be starting with the start state. The start state of NFA will be the start state of DFA. So in NFA, whatever in the phi tuple, whatever is the start state is Q naught, right? In NFA, start state is Q naught. In DFA also the same thing we will make as the start state. Okay, so in this step there is no change in the start state. In NFA also it is Q naught itself. In DFA also it will be Q naught only. And then from there on we have to find out the transitions. So how we will be finding out is for each state Q1, Q2, Q3 so on up to Qi in Q dash, the transition for each input symbol sigma can be obtained as dou dash of Q1, Q2 so on up to Qi comma A is equal to dou of Q1 comma A. Yesterday the same procedure we have followed, right? Yesterday when we have dou dash of Q1, Q2 comma A, we have followed a similar transition. So there we have used dou dash only. Here we are using dou of Q1 comma A. This dou dash is the new transition that we are trying to find out, that we will be finding out with the help of dou, the already existing transition. Dou of q1 comma a union, dou of q2 comma a union, so on up to dou of qi comma a. So now add the state q1, q2, so on up to qk to DFA if it is not already added in q dash. Here we are trying to find out a result, right? So that result you have to check in the transition table of NFA. So if that is not there in the table, then we will be adding that to the transition table of DFA. Just listen the steps. At this moment it will be a bit confusing only, but when you solve the problem it will be clear. Just try to understand the flow. First what we did is we have tried to calculate a new transition, that is dou dash of q1 q2 so on up to qi comma a. So this can be calculated with the help of dou of q1 comma a union, dou of q2 comma a union, dou of qi comma a. I got some result. So, let the result be q1, q2, so on up to qk. Unmute yourself. Okay. So now, after finding the states, we are adding the new state, whatever new state we have obtained. If it is not already there in the transition table, that we will be adding. And then find the transition for each input symbol sigma from this particular state. The newly added state is there, right? So from that newly added state to all the input alphabet, we will be finding out some more new states. Okay, so like that you have to keep on proceeding. Whenever you are obtaining a new state, on that new state with the input alphabet you will try to calculate the dou cap transition. So if that is giving you a new state, then once again you will calculate for that new state. Suppose if it is not giving you any new state, then we can stop the process. We can stop the process if there is no new state that is generated. And then we will be, as usual, we will generate the transition table. And in the transition table, once again, we have to say which is the final state. Okay. So here the final state will be identified as, just see the step 3. For the state q1, q2, so on up to qn belongs to q dash of DFA. If any one state qi is the final state of NFA, then q1, q2, so on up to qn becomes a final state. Okay, so that means, say suppose q2 is my final state. Whenever I am generating this dou cap transitions, suppose if I have a new state like q1, q2, q3, here in the result I obtained q1, q2, q3. Since q2 is there as one of the result, we will be making this entire new state q1, q3 also as my final state. Okay, so now let us see step by step how to do. Let us take this question. Let m is equals to, the transitions are given. So the q0, q1 are the states that are used. Only two states are there. The input alphabet is 0, 1. Dou is the transition of NFA. Q0 is the start state. Q1 is the final state. And here the transitions are also given. Dou of q0, 0 is q0, q1. Dou of q0, 1 is q1 alone. Then dou of q1, 0 is 5, no transition. Dou of q1, 1 is q0, q1. Okay, so for this you have to construct the equivalent DFA. So to do that, first we need to convert this problem into a solution. So in that, the first step that we will be doing is whatever is the given information, using that first we will draw the transition table. Okay, so let us try to draw the transition table. So here we have the transition table. Q naught on 0, Q naught Q1, Q naught on 1, the transition is only Q1, Q1 on 0, it is 5, Q1 on 1, it is Q naught Q1. So this is the information that is given. So based on this information, I have just drawn the transition table of DFA. That's all we have done. So far we have not entered into the solution. Whatever is the information is that is given in the question, that information I have converted into transition table. Now let us move on to the procedure once. So what is the first step? The first step is the start state of NFA will become the start state of DFA. Okay, so here what is the start state that is given? Q naught is the start state. So the start state of this NFA will become the start state of our DFA. Okay, so our DFA, the phi tuple of our DFA is defined as M dash is equals to Q dash, sigma dash, dou dash, sorry, not the sigma dash, sigma will be the same, sigma, dou dash, Q naught dash, F dash. So now the initial state is Q naught. So in our DFA also, this Q naught only will become the start state. So now in the table, you just observe the entries. Okay, Q naught, Q1 is one entry, Q1 is another entry. And along with that, I also have the Q naught as my start state. So now these are my new transitions for which I have to calculate the dou cap transition. I repeat this step once. In our resultant DFA, Q naught will be one state. Okay, and then from the table, you can observe that Q naught Q1 is one more entry and Q1 is one more entry. Q naught Q1 is repeated twice. I can calculate only once and the result I can duplicate. Okay, so we will be calculating the dou cap transitions for Q naught Q1, Q naught Q1. Is it clear up to here, ma? Is it clear? Response. You can type in the chat box also. No response. What's happening? Somebody respond. If you're not understanding, say, ask me to repeat. Only Kishan is responding, yes. What happened to rest of the people? Pooja, Priya, Nikita, Priya. 69 people are there. Out of that, only 2-3 people are responding. 69 to 70. What about the remaining? Shall I repeat again? Okay, so not many responses. That means they need this to be repeated again. Only two things we have done. The first one is whatever is the start state of DFA, the same thing I made as the start state of our DFA. Okay, so Q naught is the start state. So this is our start state in the DFA. Then some more new states also should be there, right? So for those new states, one is Q naught, and the new states that we have seen is in the table. Just see the procedure once. For each state, Q1, Q2, Q3, so on up to Qi in Q dash, the transitions for each input symbol can be obtained. So whatever is the transition that you are seeing in the table, for that we will be calculating new transition on the input alphabet. So here in the table, we just observe the columns. So here the information that I have Q naught on 0, it is transitioning to Q naught Q1. So this is one new state. We will be treating this as a new state and Q1 as a new state. So for these, we will be finding out the dou cap transitions. So for Q naught and for Q1, we have to find out for Q1 also we need to find out, and Q naught Q1 also have to find out the dou cap transitions. So now let us try to find this out. Already I have the transitions for Q naught and Q1. So for Q naught on 0 I have a resultant 1, Q naught on 1 also I have a resultant 1. And similarly for Q1 I have. The only information that I don't have is for Q naught Q1. So for this we need to calculate on the input alphabet 0 as well as on the input alphabet 1 also we need to calculate. So let us try to calculate dou cap of Q naught Q1 on input alphabet dou cap of Q naught Q1 on the input alphabet 0 I need to find out. So what is the formula for this? The formula for this is dou of Q naught comma 0, Q naught on input alphabet 0 union dou of Q1 on 0. So now let us see what is the transition dou of Q naught on 0. What is the result? Let's see. Q naught on 0, it is Q naught Q1. And Q1 on 0. Q1 on 0, it is 5. Q1 on 0 is 5. So my result will be Q naught Q1 the result is Q naught Q1. Similarly, let us find out for the input alphabet 1 also. I have found it out for input alphabet 0. The same thing we have to find out for 1 also. So let us find out dou cap of Q naught comma Q1 on 1. So this we will be calculating using the dou transitions, that is dou of Q naught on 1 union dou of Q1 on 1 Q1 on 1. From the transition table, let us take these two. Q naught on 1. Q naught on 1. The result is Q1. Q naught on 1. The result is Q1 union Q1 on 1. The result is Q0 Q1. So now when I perform a union operation on these two, what will be the result? When we perform union on this, what will be the result?
Q0 Q1 Q1.
Q1 need not be repeated twice, only once we can write. When you perform the operation of union on sets, if a number is repeated twice, we will be writing only one. That is Q0 Q1. Okay. So in both the cases, dou cap of Q0 Q1 on 0 has given me a result Q0 Q1, and similarly dou cap of Q0 Q1 on 1 has given me a result of Q0 Q1. Okay. So these are the states we have taken already. So now here in the result, I didn't have any new state. So I can stop at this point. Suppose here instead of Q0 Q1, suppose if I got it as Q0 Q2, say suppose. So then this is my new state. I don't know what will be the transition for this particular one. Okay. So in that case, again we need to calculate for this Q0 Q2 on the input alphabet 0 and 1 again. But here I got Q0 Q1 only, which is already an existing one. Here I have founded out the new transitions for these two. So I can stop here at this point and we will start tabulating for this DFA. So using this information, we will be tabulating for the DFA. So I'll just show you both the tables so that you will be clear. Okay, so first let us draw it for the NFA. So in NFA, the states that I have is only Q0 and Q1, two states. The input alphabet is 0, 1. So Q0 on 0, we got it as Q0 Q1. This is the information that is given already. We are not doing anything new. Q0 Q1 it is. And Q0 on 1 it is Q1 alone. And Q1 on 0 it is 5. Q0 on 1 it is Q0 Q1. So this is the information that is given. This is the given NFA which is given in the problem. So based on this, we are identifying our states for the resultant DFA. So in the resultant DFA, what will be the states? Let us see. So the states are, first we have seen the start state is Q0 in NFA. So the same thing we will take here. The final state is Q1. So let us take that also. So now in the DFA table, the entries will be all the unique entries in the table. In this table, in this information, whatever unique entries are there, all those will be the states in the new resultant DFA one. One second, I'm doing it. Q0 is the start state in NFA. So here in our DFA also we will make Q0 only as our start state. And then all the unique states we need to observe, I told you, right? So Q1 is my unique state and Q0, Q1 are the unique states. So that we need to fill up here Q1 and Q0, Q1. And this we will be writing inside square brackets to indicate that this is a transformed state. In NF, from NFA, these are the unique states that we have observed and we are taking as a states in DFA. So to indicate that we will be denoting them inside the square brackets like this. So these are my new states now. What I did, Q naught is the start state in NFA. The same thing I have taken as a start state in my resultant DFA also. And the input alphabet is also one and the same. The input alphabet is 0, 1. Input alphabet is 0, 1. So now Q naught on 0. Already I have the transition. If for whatever I have, the same thing I will be taking for whatever state, or for whichever state the transition is not available, for that we need to calculate. So for Q naught on 0 I already have, so no need to compute again. It is Q naught Q1. So the same thing we will be taking. Q naught on 1 is Q naught on 1 is Q1. Similarly, Q1 on 0. Q1 on 0 it is 5. Next Q1 on 1 it is Q naught Q1. Next Q naught Q1 on 0 on 1. We have just computed, right? What we have computed? Let us see. Q naught Q1 on 0. It is Q naught Q1. And similarly, low cap of Q naught Q1 on 1 is Q naught Q1. So that means on 0 also the same result, on 1 also the same result. So on 0 I have obtained Q naught Q1. Similarly, on 1 also I have obtained Q naught Q1. So now I should also identify the final state, right? I have completed the transition table. Start state we have identified. Is it clear up to here, ma? Up to this part, is it clear? Respond. Are you following? Want to respond with the great difficulty. Okay. So I should also identify. Okay, fine. I should also identify what is the final state. In the NFA, the final state is Q1. Okay, so as per our procedure, since Q1 is the final state, so here also we will make it as a final state. I will indicate that with a star. No? Anything is okay, either a circle or a star, both indicates a final state. Okay, Q1 is my final state. So now in this new state, Q naught Q1 is my new state. So in that Q1 also is there. So I will make this also as my final state. Q naught is extra, but still Q naught is there, right? So Q1 is there. So because of this, we need to make Q naught also as my final state. So two final states are there. Now I'll show you the procedure once. Q naught of NFA is the start state in DFA also. And then for each state Q1, Q2, Q3, so on in Q dash, the transition for each input symbol, okay, it is obtained as dou dash of Q1, Q2 on 0 we have calculated as dou of Q1 comma 0 union dou of Q naught comma 0 union dou of Q naught comma 1. I got the result as Q naught Q1. So now this is my new state. This will be treated as my new state. But this state is already there in which I have taken. So now add the state Q naught Q1 to DFA if it is not already added in Q dash. But here we have already added. Here along with Q naught Q1, I have already added Q naught Q1 as my one new state of DFA. So I need not add it again. If it is not been added, we need to add it. Then find the transitions for every input symbol from sigma. If it is a new state, again you need to repeat the procedure. If there is no new state generating, then stop the process after finding all the transitions. So that's what we have did here. After finding the transitions with the new state that we have identified is Q naught Q1. So for this, I have calculated dou cap of Q naught Q1 on 0, input alphabet 0. I calculated similarly on the input alphabet 1 also what is the transition we calculated. This didn't give us any new state. Again, it has ended up in Q naught Q1 itself, which is the state which is already existing. So we will stop the process. Okay. If there is no new state generating, then stop the process after finding all the transitions. Yes, I have stopped. And then we have also calculated the final state. For the state Q1, Q2, so on up to Qn belongs to Q dash of DFA. If any one state Qi is a final state of NFA, then Q1, Q2, so on up to Qn becomes a final state. If any one state. So let us see. If any one state of NFA is associated with the new state of DFA. Yes, in this state, Q1 is the final state in NFA. Q0 is associated with this Q1. So I am making this state also as my final state. And finally, we have drawn the transition table. So now for this table, we have to draw the transition diagram. So let's draw the transition diagram for it. How many states I need to take? How many states I need to take?
3.
2?
3, ma'am.
3. 3 states. And here, so suppose if you want to indicate that these are the new states, you can rename these states also. That possibility also is there. Suppose if you are renaming, you have to make it clear. Okay. So you can, because you are transforming the given NFU into a DFA, right? So it can also be renamed. Okay. So let A, so Q0 can be labeled with A. If you doesn't want to relabel also fine, no issue. Let us take B as Q1. And let us take Q0 Q1 as C. The state Q0 Q1 we are renaming as capital C. Yes. So now let's draw the transition diagram. So which is the start state now? What is my start state?
A.
A. So from this start state, I am moving to 2 states parallelly. So A is my start state now, and the transitions I have is 0, 1. So Q naught Q, sorry, so this is Q1, sorry, Q naught Q1, right? So A on 0, it is transitioning to Q naught Q1. So the name that is given to Q naught Q1 is C. Next, Q naught on 1, it is transitioning to Q1. The name given to Q1 is B. Yes. So I finished the first row of the transition table. Next, second row, Q1 on 5. Q1 is B. So how to make B as my final state and also C as a final state, because Q naught Q1 is also a final state. So these two will be made as a final states. Okay, so Q naught on 0, it is 5. Q1 on 1, it is transitioning to Q naught Q1. So that means it is transitioning to C. From B to C, it is transitioning. And here the input symbol is 1. Okay, fine. Next, Q naught Q1 on 0 as well as on 1. It is transitioning to Q naught Q1 itself. So I need to take a self loop on C, self loop on C with 0, comma 1. If you have confusion in relabeling, then you can use the same states Q naught Q1, Q naught Q1 only you can use, no issue. So here you can see the transition graph. So like this also you can represent. So Q naught, Q1, Q naught, Q1. I have not relabeled it, the same thing we have used. So here on the same label giving 0, comma 1 means you have a self loop with 1, you have a self loop with 0. You need not give like this, you can give in the same self loop labeling with 0, comma 1. So you can also draw like this, or else you can relabel them and draw it like this. So anything is fine. Is it clear or any doubts in this? Okay. So out of 69 strength, only 3-4 people are responding. Oh, what about the remaining people? Are you listening? Are you there in the class? So now, as a homework, let's take one and you do for this, and I hope you will get lot more doubts. Okay, so when you practice, then only you will get the doubts. No, not. All of you take this one. I will not be posting in the Google class. You take this question, and tomorrow some of you need to present this. Take it fast, my it's time for next class. So better you take it fast. This is Q naught. Q1. 0 comma 1, and here also we have a self loop on Q2 with 0 comma 1. So for this NFA you have to design an equivalent DFA. For this NFA you design an equivalent DFA. Have you taken? Those who have taken can leave the meeting.